We just had to finish up quick. We just think there was one problem we didn't get to, and just tie up a few loose ends, and then we're done with this section of notes, which is the end of the chapter. Okay. So I gave you the homework that I'm signing today. So you guys are gonna have most of the period to work on that because there's not a lot of stuff we have to talk about today with errors and power. Okay. Okay, so starting, let's go over real quick. Okay, so there are two things that can happen, in a hypothesis test, right? Reject, fail to reject. Those are the two conclusions that we get, right? With those two conclusions comes the possibility of an error, right? We're not talking about an error in calculations. We're not talking about necessarily a mistake. We're talking about just something went wrong, okay? So a type 1 error is when you reject in your conclusion, but you shouldn't have, right? Because the null hypothesis was actually true. Okay. Or a type 2 error where you fail to reject. We don't have enough evidence. We lack evidence, but really you should have rejected, right? Just the sample that we took didn't reflect what was really going on. Okay. And then power. Power is good when we reject a false claim. You want to reject a false claim. If something is not correct, if something is not true, then you want to reject it. Okay? That's what we talked about. So we went through, we did some examples, right? Couple of things before we double back. The probability of making a type 1 error. So the probability of making a type 1 error will always be the same as your alpha for that problem, whatever it is. Because let's say it's 5%. You can only reject in this area here. You can't reject anywhere else. So if you can only reject in that tiny area, that's the only place you can make a mistake, an error. That's the only spot you can make an error. So because of that, we say that whatever alpha is your probability of making a type 1 or a type 1 error. Okay? Power. What's the probability of power? 1 minus a type 2 error. Now a type 2 error, they won't, how do I say this? You don't have to calculate it. You won't have to calculate type 2 error. Okay? You won't have to calculate a type 2 error. I'm trying to think. It's not something you have to calculate. It's more of an idea of how to figure it out. They might ask you to figure out the probability of a type 2 error, but it's not really calculations. It's just kind of understanding what a type 2 error is. So I don't want to say that they never ask you to calculate a type 2 error, but if they do ask you, it's more of a, not necessarily calculations, but it's more of if you know what a type 2 error is. Okay? So how do you figure out power? 1 minus a type 2 error. Okay? Okay, so this example here. Go to this example. It's the one right before second to last slide. Okay? So what I want you to do is read this. I'll give you a few minutes to read it and then answer ABC. Okay? And then we'll talk about it in a few minutes. All right. So in the preceding, let's see, we're testing new vitamin tablet that claims to lower the risk of a child developing ADHD. Okay. So 0.11 was the current percent. 11% of all children will develop ADHD in the United States. That was from an earlier problem we did on Friday. And then they developed a new tablet that claims to lower. Okay, so that's why the alternative was it's going to be lower than that. Okay, P is the true proportion of all children, like those in the study, who would go on to develop ADHD when given the new vitamin tablet. They say that the children who take the tablet, out of the children who take the tablet, less than 11% of them will develop ADHD later in life. Okay, because 11% is what it currently is at. Okay, earlier we mentioned the power for a 5% significance level using 200 was 0.937. 0.937. Okay, determine whether each of the changes would either increase or decrease the power and explain why. Okay, so if I was to raise my significance level instead of 5% to 10%, would that increase power or would that decrease power? It would increase power. Yes. It would increase the chances that you correctly reject a false claim. Why? Why is that true? Why would it increase? You're right, it would increase. Why is that true?
There's more leeway. It's a larger scope, so there's more space for you to say this is wrong, this is not.
Yeah, exactly. The threshold for rejecting is a lot lower, right? If we increase alpha, it lowers the chance of a type 2 error. If we lower the chance of a type 2 error, if we lower beta right here, I'm subtracting by a lower number, right? So if I'm subtracting by a smaller number, power is going to be bigger. Okay? So it's a less amount of evidence, less evidence needed to reject. It's less evidence that I need to reject the claim. If it's not as a tall of a mountain to reach, more people are going to get there. Okay. What's the problem though with increasing power or increasing significance level?
It's easier to get a type 1 error.
It's easier to get a type 1 error. Yep, because type 1 error goes up to 10%, right? So type 1 error is rejecting when you actually shouldn't have, right? So letter B. If the true proportion is 0.08 instead of 0.05. True proportion. So where do they get that number from? Yeah, but the power just check. So I'm guessing that out of the kids, so I see the number here, but I'm trying to see what they're referring to there. And it's this number right here. So you got kind of like two, I don't want to say populations, but because you have one group here, that's all kids that have already developed the disease. All kids. So this is not necessarily referring to kids, it's referring to teenagers, 4 to 17. People who have already got ADHD. 0.05 is the number of kids from their sample who went on to develop it, right? So out of their sample, they said, hey, we only got 5% who developed it, whereas the national average is 11%. Okay? So what if their number was actually 0.08 instead of 0.05 in their study? Would that increase power or would that decrease power? Because Yeah, we're getting closer to the null hypothesis, right? Getting closer to what to this number here. If you get closer to it, you're more likely to make errors. So it would decrease power because of that. Okay. Closer P to null hypothesis. Okay. And then the last one, if instead of they use 500 in their sample, I think it was 3-year-olds that they were focused on. So they had 500 3-year-olds as opposed to 200. Would that increase or decrease power if they raise the number in their sample size? It would increase. Yep, sample size. If you increase sample size, good things happen. Because it lowers the chances of a type 1 error and a type 2 error and increases power. Okay, just because it's the law of large numbers. The more you get, the more it's going to represent the population you're representing. So the bigger the sample, the more likely it's going to represent what's really going on. Okay. All right. Okay, so done with that. So I'm going to give you the rest of the time to start on your assignment. So the assignment is from your book. I made a copy for you guys to get started. So I want you to, the first